The producers and distributors of Tech AV technical training aids welcome you to this program in the Refrigeration Maintenance Series. This program continues the servicing procedures which we began in program number ACR 3. During this program, you will learn how to conduct a typical refrigerant charge procedure to an air-cooled, semi-hermetic commercial refrigeration unit. We shall also overview some important and useful maintenance tips. You will recall that we concluded the previous program with an evacuation of the system in order to remove all traces of air and moisture. The system was left standing in vacuum, and this is where we shall now pick up on the next procedure, which is to introduce the necessary mass of refrigerant into the system. The desired objective of this process is to achieve an optimum charge given that we do not have manufacturer's specifications. During the process, we shall be using certain diagnostic and testing aids to help us achieve our objective. In practice, there are two conditions which we must avoid, namely, an overcharge system and an undercharge system. Let's overview each situation. Overcharging implies that the system contains an excess of refrigerant, which of course can lead to problems. Let's see what they are. Let us assume that a system has no receiver. We'll explain why a little later. In our diagram, liquid has built up in the liquid line right back to the condenser and has occupied more condenser loops than usual. This would be a typical overcharged situation. With the expansion valve behaving normally, it will only permit so much fluid to pass into the evaporator. In effect, the liquid behind the valve is backing up, waiting to get through. As more and more refrigerant condenses, the condenser coils will become increasingly filled with liquid. This effectively reduces the capacity of the condensing area within the coil. However, the compressor simply goes on delivering more vapor than can be condensed in the limited space. The result is a pressure rise in the discharge line. Two clues which point to an overcharged system are excessively high discharge pressure and high current draw by the compressor motor. Receivers reduce the possibility of an overcharge as they hold in effect some reserve space into which surplus liquid can be stored. Typically, a receiver would be approximately 80% full if it were to contain the entire refrigerant content of the system. However, a gross overcharge situation would result in flood back to the condenser as previously described. Let us now discuss the problems of an undercharge system. When insufficient refrigerant is in a system, the condenser will not be able to provide enough refrigerant to create a liquid seal. As a result of this, the expansion device receives vapor, or at best, a mixture of vapor and liquid, which we call flashing. In this state, the desired mass of refrigerant cannot be metered into the evaporator. A reduced volume of refrigerant in the evaporator means that less heat will be removed from the cooling area. It will also result in a superheat rise. Further, the compressor will be attempting to draw in vapor to satisfy its cylinder capacity. But as insufficient vapor is present, a significant drop in suction pressure will occur. After the break, we shall commence with the preparation for a vapor charge to our demonstration unit.